Hi everyone. I am Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College, Sorampalam. In my last video, I explained about hydroelectric power plant. Now in this video, we will continue our discussion to get insights about steam power plant. Yes. Now we are seeing the thermal power plant. So we are seeing some different items in the screen, but the main concept is now you can see the main concept is the heat energy is converted into electricity, right? So now you are seeing some diagrams here. This is boiler, this is turbine, this is power grid. Before that, we are having generator, right? Boiler, turbine, and generator. These three are the essential components of power plant. Okay. So the all others are simple added one. Simple added one, right? These are the main roles: boiler, turbine, and generator, right? Because the power plant means turbine is to rotate and it is to be coupled with generator, right? So the main aim of any power plant is to rotate the turbine, rotate the turbine, okay? So how you rotate the turbine, it is immaterial, right? So if you are able to rotate by means of steam or by means of some other water power or steam power or by some other means, it is immaterial, right? So in this case, the steam is hitting the turbine and rotate the wheel. So the steam energy or steam power that is hitting the turbine, right? So how the steam is generated? Steam is generated in the boiler, right? Now, to the boiler, how the heat is coming? Whether the heat is coming by the gas or burning of the fossil fuel like coal or by means of some other burning of gas, burning of some other fuel, right? It is immaterial. So, heat is coming by some source. And in the boiler, the water will be boiling and it is generating the steam and the steam will hit the turbine. Okay. So what is this attached one, right? So this is related to the water circuit and this is cooling tower, right? One by one, I will explain each and every item. Listen very carefully. Identify the main components: boiler, turbine, generator, right? Okay. So to the earlier diagram, there is small difference. What is the small difference? Coal. Coal means I am getting the heat energy to the boiler by means of coal. So this is from coal storage. Coal will come through some transport system and it is fed into the boiler, and here the burning of coal will be done. Due to the burning of coal, water will get heated and steam will be generated, and the steam will flow through the pipes and it is heating the turbine, and rotating of the turbine will give you power, right? It is very simple circuit. So you can create a line diagram by means of the names itself. Okay. So how to get the names? So this is boiler, right? So you can put a round or a square, and this is turbine. Turbine is coupled to generator. You can make a box here, and the boiler is attached to water treatment plant. And this integral part is called condenser. And these are the water pipelines, and this is cooling towers, or you can write the cooling system, right? And this is feeder, or you can call coal feeder, right? And it is, you can write here the heat. Okay. So by means of either names or by the diagram itself, you can create a circuit. Okay. Boiler to the turbine, turbine to the generator, and boiler is having the connections to the coal burning, and to the coal burning grate, coal feeding pipe is there, right? You can write very simply coal feeder or coal storage to coal feeder and to the burner, right? So you can attach one or two components here, and water is supplied by some pump. Here you can create a pump here or not, no problem at all, right? Because this is the skeleton line diagram. The inner parts like pumps or some other valves, right? Or the steam generating unit, whether it is Cochrane or Babcock's, whatever it might be. Simply you write here boiler, because this is fundamental circuit. Okay. Now we'll go to next level. Okay, regarding solar power plant and PV panel, wind power plant, this is very simple one. So solar power plant will go into the deep regarding steam power plant. Okay, because this is the most complex one, and we are having more subsystems, right? So let us take a small pause to solar power plant. So here the solar power plant, you are able to see in our college, we are having solar power plant. So it is very easy. The generation of energy is easy because we are having panels. We are calling PV panels, photovoltaic panels, right? From this directly the DC energy will come, and through the controller we are storing the energy in the batteries and we are converting into AC, right? So this is called a PV panel. Here we are having the semiconductor cells inside. So by this we are able to store the energy in the batteries directly. From the batteries through inverter we are getting the energy. Just like in the household we are having inverter coming back to the AC power, DC power to AC power, right? And this is regarding the wind power plant. Wherever we are having very high wind area, there we are incorporating at a high altitude level the wind power plant. So a stem-like structure will be there. So at the end, we are putting some generator here. So to this is called the wing or blade, right? So by means of the rotation of this one, this is called hub, this is called generator, right? So this is the skeleton. By means of the air, this will be rotating like this, and by this rotation of the hub, electricity will be generated and it is transmitted. Now you are having the programmable logic controller. Why we need to have the programmable logic controller? Because controlling aspect means depends on the demand. Demand means electricity demand. Depends on the demand, the generator has to generate the energy, right? But the generator cannot generate on its own. It is coupled with turbine, right? And turbine itself cannot generate the energy. It is by means of the driven force of steam or water or something, right? So generator and turbine both are basically static. They cannot do anything on their own, right? So somebody has to hit the turbine, then only I will get the energy, right? So I need to, if I need to control the demand, right? I need to generate the energy equal to demand, right? So if the demand is excess, I need to produce more. If the demand is less, I need to down the generation, right? So I need to have some balance to make the balance, I need to have some adjustments. These adjustments we are able to do by controlling different aspects. What is to be controlled? If I want more energy, so more steam is to hit the turbine, right? In a particular time period, maybe for 1 minute or 1 hour, okay? So if I want to get more steam, boiler is to work more, right? Boiler is to work more means more water is to be fed and more heat energy is to be given, okay? Right? So when more heat is to be given and more coal is to be fed into the boiler, okay? Like this, either I need to have the plus or minus, right? So manually controlling is very, very difficult because by the time I am having the demand here and by the time the adjustments are completed, right, the demand may increase or decrease. So by means of the electronic circuits, if you are able to control the boiler or your coal feeding, water, right, generation of the plant, or otherwise controlling of the steam directly to the turbine. So by means of the programmable logic control, generally we are calling with the name PLC, famous. Okay. So by means of this, you are able to control electronically without any manual intervention. Now we'll go to the deep. Okay, this is recording all this. I will share this PPT with all of you. Now we'll deal about the thermal power plant. Okay. So these are the different contents, working principle, general layout, what are the main equipment, and how the waste generated and their control advantages. Okay, this is all regarding the general history of the thermal power plants. What is the importance? Okay. Right. So the basic working principle, if you are given a question regarding the working principle of a steam power plant or thermal power plant. So either you can call a steam power plant or thermal power plant, whatever it might be. The main hero is steam by the boiler, and it is heating the turbine, and we are getting energy, right? So what is the working principle? First, the water will be taken into the boiler from a water source, and the boiler is heated with the help of coal, right? Because you are heating with the coal, you call it as coal-based thermal power plant, okay? The increase in temperature helps the transformation of water into steam. We know very well from the boiler knowledge. The steam generated in the boiler is sent through a steam turbine, okay? The turbine has the blades that rotate when high velocity steam flows across them. So there is some wheel and the blades are there and they will rotate like this. And this rotation of turbine blades is used to generate electricity. And a generator is connected to the steam turbine. When the turbine turns, electricity is generated and given as output by the generator, which is then supplied to the consumers through high voltage power lines. Very simple. So I will draw here. This is the boiler. Boiler to turbine. Turbine is coupled with generator. Don't put any arrow mark here. Turbine is directly coupled, right? And from the generator, electricity. And to the boiler, we are supplying heat by burning of coal. This is a very simple skeleton diagram of a steam-based power plant. Okay. Now you identify one by one. See, this is boiler. Okay. So fuel. Fuel means what is the input energy, right? And it is coupled to the turbine. So this is the basic structure of a turbine and turbine to alternator, three-phase supply. Okay. So whatever I am showing here, it is the main thing. To this main thing, we are adding one by one by one, right? One second. Okay, color. So to the boiler, I am having some other subsystems. To work the boiler in a perfect way, to make the turbine to be effective more, we are having some subsystems, right? So there is ash handling plant, there is a precipitator, there is air preheater, there is an economizer, right? And there is a condenser, a condensate water pump, and circulating water pump, cooling tower, right? There are subsystems, right? So to make your actual main item to work in a better way, we are having subsystems, and the efficiency of the subsystems will affect your efficiency of the main plant. Now you see you are having these different items. So to the boiler, we are having coal supply, right? So how to make your coal uh, feeding or pumping or burning in an effective way, right? So you see here, coal is transported to the power station by rail or road, or stored in a coal storage plant and then pulverized, right? And the function of the coal handling plant is automatic feeding of coal to the boiler furnace. So there will be some electrical systems and transportation systems. So directly you can feed the coal directly to the boiler. A thermal power plant burns enormous amounts of coal. Example, 200 megawatt power plant may require around 2000 tons. Okay. And pulverizing. Pulverizing means, see, in the modern thermal power plant, coal is pulverized, that is ground to dust-like size, so powdered, right? Simply you can remember pulverizing means powder, okay? Carried to the furnace in a stream of hot air, and pulverizing is a means of exposing to the large surface area to the action of oxygen and consequently helping the combustion, right? And pulverizing, it consists of the three stages: feeding, drying, and grinding. We don't go into the complete details because you require only limited one, okay? Now, the function of the boiler. So there may be a small question, one more question to you. What is boiler? What is turbine? Right? What are the types of boiler, types of turbine, like this? So the function of the boiler is to generate the steam at desired pressure and temperature by transferring heat produced by burning of the fuel, right? Here the fuel may be different, either coal or gas or some other liquid fuel, solid fuel, gaseous fuel, right? So burning of the fuel in a furnace to change water into steam. This is the main thing, water into steam, right? And what is the role of turbine? In thermal power plants, generally three turbines are used: high pressure turbine, intermediate pressure or medium pressure, and low pressure turbine. And what is the role of condenser? Condenser means actually we need to convert steam out of turbine, coming out of turbine. So the steam is passed through the turbine and turbine is rotated. So after rotation, steam will come out, right? So steam coming out of turbine, what I need to do? I need to condense and I need to convert the steam into water, right? So there will be some heat exchanger. That means the energy from the steam is to be extracted out, right? So this is the heat energy is extracted out, right? So automatically the steam will be converted to water. You know very well, the water is having the three stages, right? Suppose I'm starting from the lower level, I set 0 degrees centigrade to, if the heat is given, it will become water at 0 degrees centigrade. If the heat is continued, water at 100 degrees centigrade, continue the heat, it will become steam at 100 degrees centigrade. You continue superheated steam. Go in reverse. Go in reverse. Superheated steam, you reduce the heat. So you take the heat out. It will become steam at 100 degrees centigrade. Remove the heat. Water, it will become water at 100 degrees centigrade. You remove the heat. Water at 0 degrees centigrade. Okay. Up to this, it is sufficient, but we don't go into the water at 0 degrees centigrade. So generally, we will make the water at room temperature. Generally, it will be around 35 degrees centigrade. Okay. Now, what we will do with the condensed steam, that is water. Because this water is pure water, I can send again to boiler. So the water is recycled. Okay. Now, how the heat is extracted from your water coming out of the steam coming out of the turbine, right? So this is by cooling towers and ponds. A condenser needs huge quantity of water to condense the steam, right? So the water is circulated around the tubes and the steam is passed through the pipes so that water heat is exchanged. So we are calling the system as heat exchangers, right? Most plants use cooled cooling system where warm water coming from the condenser is cooled and reused. And cooling tower is a steel or concrete hyperbolic structure with a height of 150 meter, very great height. So another subsystem is feed water heater. Feed water heater means water coming out of your condenser, it is nearly at 35 degrees centigrade or room temperature, right? So we need to heat it and again I will send to boiler, right? So generally the basic item that is attached to the boiler is feed water heater. So feed water heating improves the overall plant efficiency and the thermal stresses due to cold water entering the boiler drum are avoided. And quality of the steam produced by the boiler is increased. Suppose I am sending the cool water. Some of the energy is wasted to increase the temperature from suppose 10 degrees centigrade to 100 degrees centigrade. Suppose I am supplying water at 35 degrees centigrade. So the energy is saved. Okay. Okay. Now you are having some systems which improve the thermal efficiency. Economizer and air preheater. And there is some superheater, radiant superheater, convection superheater. Like this, you are having so many systems. So what are these systems? See, suppose I am having, okay, I will see, I will show you fuel burner. Okay. That means suppose it is coal. So flames are coming like this. Okay. So after fuel, suppose the boiler is there. Okay, this is the boiler. So water is coming like this and steam is going like this. That's okay, right? And after this, just 1 minute, I will change the color. Pointer options, color red. Okay. So surrounding, what about this gases? These are called flue gases, right? So these contain high heat, right? After making the boiler water to be heated and generation of the steam, okay, some of the heat will be transferred to the boiler, but these gases will contain more energy and they will flow through air only, right? So some of the heat will be wasted through flue gases, right? So what we need to do, we need to extract the heat from the flue gases. How to extract, right? Now I will show you on the right side some other thing. Just I am showing these are the flue gases. Okay. So from these flue gases, I need to get energy to be coming out, right? So what I will do, I need to place somebody in the path of the gases, right? Suppose I am putting some plate or I am putting some pipe or I am putting my hand, okay, anything, automatically it is getting heated. So some of the energy is transferred to this particular system, right? Suppose I am having some 80% of the heat is transferred. Some heat it will take. Suppose 10% of the heat is extracted. So 70% still is there. Okay. So I will put another system here. So it is taking some 20%. So it will come to 50%. Now I will put another system here. So it is taking some 40%. So 10% of the heat is still left. I will put another system here. Okay. It is taking some 5%. So 5% will go to air. Okay. So how much heat is extracted? From 80% to 5%. That means 75% of the heat is extracted to you, right? So how we are extracting? So there are so many systems. One is economizer. So all this economizer or superheater, radiant superheater, whatever the systems, 1, 2, 3, 4 different systems. These are used only to get the heat coming into your system, right? So depends on your need. You are putting some item here. So the first item we are putting is radiant superheater, right? It is taking direct heat. Okay. So it doesn't mean that 10%, it may take 40% or it may take 30%, right? So some heat, right? Radiant superheater, if I am putting some other system, you can call it as convection superheater. You are putting some other system, make it called economizer. I will put some other system, it is called air preheater. Okay. So I am putting 4 or 5 systems, right? I can put another air preheater, another economizer, right? Finally, my aim is don't make your flue gases go out to the atmosphere with high heat, right? So extract more, okay? Because once you are having the heated air or heated water, your system will have high efficiency, okay? See, in the economizer, I'm saying flue gases coming out of the boiler carry a lot of heat. An economizer extract part of this heat from flue gases and use for the heating feed water and saving coal consumption, and it is giving high boiler efficiency. So air preheater, why we need to heat the air? You see, in the boiler, coal is fed through one system and we are supplying the air for making the burning of the fuel, right? If you supply hot air, so your efficiency will increase, okay? And waste generated under control is the ash handling plant and water handling plant, or we can call water treatment plant. Ash handling means after generation of the energy, the coal is transferred to remove of the energy. Finally, we are getting ash, right? So what to do with the ash? So there are some waste management systems are there. So how to convert the ash into a useful item? So we are having fly ash bricks, right? So and the water is transferred to water treatment plant so that we can circulate through systems. Okay, so these are all different advantages and disadvantages. Now in the steam power plant, we'll go into a deep way. So the flow sheet of the steam power plant consists of 4 main circuits, right? So in some cases we are having with the name 5, but you remember the main thing: feed water and steam flow circuit, coal and ash circuit, air and gas circuit, and cooling water circuit, right? So this is all how the working of the steam power plant again, right? So this is the main thing. So you start with the main items. So this is the boiler first. I am saying it is 1, right? And turbine, it is 2. generator, it is 3. Okay. Now you can see one system is, this is one system attached to the boiler. What it is? Ash handling plant and ash storage, right? So this is one subsystem. Just remember only subsystems. In the subsystem, you may have 2-3 components. So here it is ash handling plant. So add to ash storage, right? And what is attached? Input. This is coal handling plant, coal storage, right? So to the boiler, we are having coal system attachment and ash handling attachment. Coal is coming inside and ash is going outside. So look at the arrows, right? Now, to the boiler, to the turbine, right? We are having inner components, right? So what are these inner components? Superheater, economizer, air preheater, right? Now you see air circuit. Just, okay, 1 minute. I will change the color so that you can understand easily, right? So to the boiler, once the coal is feed inside, I need to supply hot water. Sorry, hot air. Okay. Now you see, this is the air, right? Air through air preheater will enter into the boiler, right? Directly, air direct connection to the boiler will not be there. Air through air preheater, right? Why the air preheater is having in some other area, right? I told you earlier, it has to be passing through flue gases area, right? So that the air, suppose it is at some 30 degrees centigrade is feeded inside, right? So passing through the air preheater, it will be increased to 60 degrees centigrade. Let it be, okay? Right? Next thing, the steam coming from the boiler is enter into superheater, right? And through the main wall, through turbine. Okay. Superheater means, see here, suppose the superheater is there. I am saying here, see, this is the steam. Okay. So steam through passing through some pipes and it will go to turbine. Okay. This is the superheater. What is happening inside the superheater? See, I will change the color so that you can understand again. Okay. So what is happening in the steam? In the superheater, see here. So steam is passing through superheater and it is passed through turbine. So steam entered in the pipes and it will go to the turbine. But there is a link to the superheater flue gases. So flue gases are going like this and I am placing the superheater in the path of flue gases. I told you earlier, right? So the flue gases are passing through the pipes. That means hot flue gases are passing through steam pipes. So some of the heat will be taken by the steam and the steam, suppose it is at 100 degrees centigrade, will be transformed to steam at 140 degrees centigrade, maybe. Okay. So steam will become superheated, right? So after some of the heat will be taken by the superheater, the flue gases will pass through economizer, right? So economizer will take some heat. What it will do? It will increase the temperature of the feed water. Superheater will increase the temperature of the steam. Economizer will increase the temperature of water. Air preheater will increase the temperature of air. So 3 items. So in the path of the flue gases, I am putting 3 objects. One is superheater, take some heat to steam heating or increase the temperature of the steam. Economizer and air preheater. The functioning of these three objects same, but what is the item we are passing through? In one area, I am passing steam. In another area, I am passing water. In another area, I am passing air. Okay. So finally, the flue gases will go to chimney. Chimney means atmosphere. Okay. Now, what are the components that are left over to you? Boiler, feed pump. So the feed water is there, right? Now we are having water circuit. What to do with the water, right? So the feed water coming from some pond. Directly the water coming from like this, I can make the diagram. This is pond. From the pond directly, I can have a connection to the boiler. That means without any treating directly, the water is going to the boiler, right? Otherwise, there is a high pressure heater, there is a pump, there is a low pressure heater, right? And there is condensate extraction. Okay. Now you can see, suppose boiler feed water is coming from the directly pond, right? Okay. After the boiler is from the steam is coming from the boiler is passed through the turbine. Now, what to do with this exhaust steam? Exhaust steam is passed through the condenser. Actually, the condenser, or you can write very clearly heat exchanger, right? In the heat exchanger, the heat will be extracted from the steam and I will get water, right? So from the cooling towers, the temperature is decreased and I am getting water. These condensate means simply condensed water, right? Steam condensed to water. These water again, it will be pumped through some boiler feed pump. Again, it is going through economizer, right? Now, everything is over. So this is some layout of power plant. You need not worry about all of this. You can remember this line diagram. So these are the typical power station diagrams and what to do with this conservation of energy and the division. You can remember very clearly to make your effective presentation. Remember only the main items and attached items. Coal handling plant attached, water treatment plant attached, fuel and ash plant. It means coal handling plant, ash handling plant. You can remember feed water and steam plant and cooling water plant. So these are all attached systems. Okay. So what are the functioning of this coal plant, ash handling plant, or gas handling plant, feed water, right? So this is the coal handling system. You need not worry about this. This will not be given to you. And these are the by the wagons. We are bringing the coal, right? And this is simply the ash handling. And these are the complete number of parts of your steam power plant. So what are the different functioning main heroes, right? Boiler, superheater, economizer, and turbine. And this is the steam turbine outer view, right? So the main thing is to rotate this. Okay. Okay. What will happen after the high pressure steam is hitting the turbine, right? We will get the electricity and we will get low pressure steam out because high pressure steam will hit and kinetic energy is transformed. It will become low pressure steam. This low pressure steam will enter into the condenser and it will become water. Okay. So what to do with this feed water? So this feed water after treatment, it is again feed into the boiler so that you are having the water cycle in an efficient way. So at the end of this lecture, you learned the characteristics and working principle of a power plant, especially steam power plant. Thank you very much. If you like this video, please like, share, and subscribe. Thank you very much.